Hello and welcome to today's video. Today we're going to be taking a look at how to program an ATtiny85 microcontroller. This is for a project that I'm trying to come up with. I want to use the ATtiny as a slave on the I2C bus, just as an experiment to see if I can do a few things with it. But to do that, I needed to figure out how to program the ATtiny. So I've been playing around with that for the last few days, so let me just switch over. So I've actually put together a little website with detailed instructions. So this is more just talking through the web page. If you want, you can find the link below in the description. Please feel free to go and check it out. I've set up the website so that it gives me a place to put documents, code, anything to do with the project which I can't easily share via YouTube. So anyway, so feel free. So let's get started. So the first thing to understand when programming a device is what pins are we going to be using. So the Arduino has a sketch, and we're going to be using the SPI bus, the serial peripheral interface bus. That works through 3 lines. I haven't gone into detail about the SPI bus, but I will be creating a video on it in the near future. So the way it works fundamentally, though, there's 3 lines: the SCK, the clock line, the SIO, the master in, slave out, and the MOSI. Now it's very simple. You basically collect like with like, so SCK to SCK, MISO to MISO, and MOSI to MOSI. So if we just take a quick look at the ATtiny pinout, we can easily see that the 3 pins that we need are on the right hand side, pins 7, 6 and 5. So we found those on the ATtiny. Took me a little bit of time to figure out where they were on the Arduino Nano, because on the default pinouts they don't identify them, but the default pins for the SPI bus are here, pins 15, 16 and 17, or D11, D12 and D13. That's typically how you'll see them referenced on the Arduino Nano board. It may not reference the SCK MISO, but we can see the clock is on D13, the MISO is on pin D12, and the MOSI is on D11. So fundamentally we just need to connect those 3 lines together. We will also need to apply power and ground to the Arduino Nano. So we need VCC, which is 5 volts, and ground. Now there is also this reset line which we're going to need to connect up as well. So we're connecting up most of the pins on the Arduino Nano. The PB5 or pin 1 is the reset line. Now if you go through my website, you can see that by default we shove that onto pin D10, because that's what the default sketch from Arduino uses. But if you actually open up the sketch, you can see that the pin for the reset line is variable. It doesn't really matter as long as it's one of the digital lines. So they use D10, so I just stuck it on D10, and this is like the view on how I laid it out on the prototype board. But it doesn't really matter as long as you follow the basic connections, that will work. In the default sketch there are some LEDs which you can hook up for indication, but you really don't need them too much. Now, as I said, once we've got all of the pins connected, the next thing we need to do is actually upload the sketch. Now if we go into the Arduino, let me just open up the Arduino for you to see. My computer's going slow today. Okay. So here under examples, if we go down into examples, if you look at the bottom, number 11 here, there's Arduino ISP. That is the sketch which we're going to be opening up, and that's the one we're going to be using to become, or to make the Arduino Nano a programmer. So very simply, we have that. And if you look down here, and there are the settings which you can change for the pins. Okay. So let me just connect that up. Go Arduino Nano, and we're just going to upload that sketch. Select the right port and select the board, Arduino Nano. Okay. Okay, so once we've got that connected, if we do upload, we can just now upload that sketch to the Nano, and that's done. Okay. Once we've uploaded the sketch, the next thing we need to do is we need to add 100 microfarad capacitor. I know this says 1,000, but I mean, it doesn't really matter. In fact, anything over probably about 10 microfarads should work. And we're going to connect this between the reset and the ground pins on the Arduino Nano. The reason for this is, by default, when we go to program a sketch into or using the Arduino development environment, it will send a command to reset the device it's connected to. Well, in this situation, what it's first connected to is the Arduino Nano, and we don't want the Nano to reset. What we want to do is have the ATtiny reset. So if we add a capacitor between the reset pin and ground, making sure the negative of the capacitor goes to the ground, this will then prevent the Arduino Nano from actually resetting. And just as a side, these instructions should work for any of the Arduino development, as long as you find the right pins for the SPI interface and just follow the basic instructions, so it should work. So we've now programmed the programmer, we've now hooked up the ATtiny. The next thing we need to do is actually tell the Arduino development environment about the ATtiny. If you notice, if you did a search for ATtiny boards, nothing shows up. So we need to basically tell the development environment where to find the install files for the ATtiny boards. So very kindly, this guy has created some installs for us. So you can find them on GitHub. I've got a link in the on my web page, but you can see it here. All we need to do is copy that link into if you go into preferences, on the development environment at the bottom we have this additional boards manager URL. If we right click at the end there, you can see you have a space where you can paste in new URLs. So if you paste in that URL and hit OK again, you've now told the development environment where to find those files. Now, one thing to be careful of is the Arduino development environment needs to be reset. You must close it down, otherwise it won't update the information. So just close down the Arduino development environment, reopen it, and then if we go into board manager, and then if you type for ATtiny, you should see this show up. This guy David A. Melisses, I don't know how to say his surname, but this is the one I've installed and it appears to work absolutely fine. So once you've entered that URL, restarted Arduino IDE, we can now install these boards. Okay, so once we've done that, we're now getting close. Okay, so now we just need to open up a sketch, and to do that I'm going to open up the example sketch, basic blink. Okay, so we've got a blink LED, the very famous first test. Now this is where we need to change a few things. The LED built-in is not going to work. What we need to do is we need to go back to the pinout, and we're going to use one of these pins. Now we don't want to use the PB5. This is a reset pin. We could if we had to, but we would need to change the configuration of the ATtiny. But we can use any of the other PB lines without any issue at all. So if you do pin 0, that's going to be actually pin 5. Pin 1 is going to be pin 6. 2 is 7. 3 is going to actually be physically pin 2, and 4 is pin 3. So you've got to be a bit careful with between the physical pin port and the actual. So if we just use PB0, we know that's going to be pin 5. Okay, so what I've done here is, you'll see in the video, is I've actually taken that prototype board and I've just soldered it together onto a dedicated board with a ZIF socket. A ZIF socket is a zero insertion full socket. It just means I can take the ATtiny in and out without any risk of damaging the pins. Okay, so let's got that running. So we have the sketch. I've changed the pins to pin 0. Now the final step is programming. So step 1 is on the board. We're now going to select ATtiny, and I've got the 85. We are now going to set the clock speed to be 8 megahertz internal. That's the default speed for the ATtiny internal. The processor we're going to set to ATtiny 85, and the programmer we have to set as the top option Arduino as ISP. I know that there is loads of other ones, arduinoisp.org, Arduino ISP, Arduino ISP 80 mega. We are going to use the Arduino as ISP, which is the top option. Okay, so we've now done all that. The final thing to do is upload this blink sketch. Now don't go to upload like you normally do, just go beneath it, upload using a programmer, and click that. Okay, also set the port, upload using programmer, and we can now see the green light flashing, and we have uploaded the sketch now to our Nano. So we now have the Nano programmed as a blinking LED. So when we have power to it, it will flash pin 5, which is D0. Okay, so let's just quickly hook it up and double check that. So blink is working. So that's basically the steps involved with programming the ATtiny. In a video I'm just about to put up, I programmed the ATtiny as an I2C slave. So if you're interested, stay tuned and watch out for that video. But thank you for watching. Bye for now.